Welcome to our guide on mastering Python Lambda functions. In this video, we'll dive deep into understanding Lambda functions in Python, covering everything from their definition to practical examples. Let's start with the basics. What are Lambda functions? Definition: Lambda functions, also known as anonymous functions, are small, inline functions that are defined using the Lambda keyword instead of the def keyword used for regular functions. Syntax: the basic syntax of a Lambda function is Lambda arguments, expression. It consists of the Lambda keyword followed by a list of arguments, a colon, and the expression to be evaluated. Example: Lambda x, yx plus y. This defines a Lambda function that takes two arguments x and y and returns their sum. Use cases: Lambda functions are often used in scenarios where you need a simple function for a short period of time, such as in list comprehensions, sorting, filtering, or mapping operations. They are especially useful when you need to pass a function as an argument to another function. Advantages: conciseness. Lambda functions allow you to write small pieces of code inline without the need for a separate function definition. Readability. In some cases, using Lambda functions can make the code more readable, especially when the function is short and the context is clear. Limitations: limited functionality. Lambda functions are restricted to a single expression, so they can't contain multiple statements or complex logic. Limited debugging. Since Lambda functions are anonymous, debugging can be more challenging compared to regular named functions. Scoping. Lambda functions have their own local namespace and can access variables from the enclosing scope, i.e., the scope where the Lambda function is defined. However, they can't modify variables from the enclosing scope unless those variables are declared as global or non-local. Returning values. Lambda functions automatically return the value of the expression they evaluate. Now let's see it with coding examples. Let's break down each of the coding examples provided. 1. Using Lambda in a map function. Now there. List_numbers is a list containing 1, 2, 3, 4, 5. The map function applies the given Lambda function to each element of list_numbers. The Lambda function Lambda x 2 squares each element x. The result is a new list _numbers containing the squared values of the elements in list_numbers. 2. Sorting a list of tuples based on the second element. Now here. Pairs is a list of tuples 1, 1, 2, 2, 3, 3, 4, 4. The sorted function sorts the list pairs based on the value returned by the Lambda function. The Lambda function Lambda pair 1 extracts the second element of each tuple, pair 1, which is a string representing a word. The sorting is done based on the alphabetical order of these second elements. The result is a new list sorted _pairs containing the tuples sorted alphabetically based on their second element. 3. Filtering even numbers from a list. Now in this example, numbers is a list containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The filter function applies the given Lambda function to each element of numbers and returns only those elements for which the Lambda function returns true. The Lambda function Lambda x %2 == 0 checks if each element x is even, i.e., divisible by 2 with no remainder. The result is a new list even _numbers containing only the even numbers from the original list numbers. These examples illustrate how Lambda functions can be used in various contexts to perform simple operations concisely and efficiently. Let me know if you have any further questions. And that wraps up our comprehensive guide on Python Lambda functions. I hope you now have a better understanding of how Lambda functions work and how to use them effectively in your Python code. Thank you for watching.